And I would like to say good morning to all of you and welcome you to this webinar. My name is Themis Sarantaenas, and I'm delighted to be your host today on behalf of AMS. Thank you all for joining us as we explore the Greek demo in Peristeri, Athens, a truly remarkable project that exemplifies how innovation and sustainability can transform the energy performance of older buildings. The purpose of today's webinar is to showcase the groundbreaking renovation of a 1981 building in Peristeri. This project has applied cutting-edge technologies and innovative solutions to achieve a spectacular transformation, making the building energy efficient while setting an example for similar initiatives. We are honored to have a distinguished panel of speakers who will guide us through these various aspects of this transformation and share insights into the innovative technologies implemented. The webinar will also serve as an excellent opportunity for discussion and networking among professionals who share a passion for sustainable development and energy efficiency. Let me quickly walk you through today's agenda. We will begin with a brief overview of this project, Surefit project, by our coordinator, Sergio Tadeu from ISQ, followed by a presentation of the Greek demo by Pappa of AMS, who will detail the journey of the building from pre-renovation to its impressive post-renovation state. And we will proceed with Pedro Vilela from CZR, who will present the prefabricated facade panels, and Mahmut Buker from SOLIMPEKS, who will discuss the PV thermal system. Finally, Chris Benson from UNOTT, who is online, I guess, because he's not in his office today, but he has pre-recorded his presentation. We'll talk about the PV vacuum glazing window. After these presentations, we will continue with a 20-minute Q&A session where you will have the chance to engage directly with our speakers. And finally, I will wrap up the session with a few closing remarks. Once again, thank you all for being here. Your interest and participation is crucial in driving the conversation around energy efficiency and sustainable building practices. So let's get started. Sergio, the floor is yours. Let's see your presentation also.
Good morning, everyone. Do you have my presentation or not?
Yeah, we will share it now.
Okay.
Give us a sec.
Before we discuss the application of Surefit technology in the Greek demo building, let us briefly introduce what the project consists of. Surefit is funded by CINEA, the European Climate Infrastructure and Environment Agency, in 3.5 million euros. Surefit aims to demonstrate the fast-tracked renovation of existing domestic buildings by integrated, innovative, cost-effective, and environmentally conscious prefabricated technologies. In short, it aims to achieve reduction of prime energy use, carbon emission, cost, and time for renovation. It's clear that cost is a difficult goal or target for this project, but we have to admit that these targets are going to be achieved also after the project ended. Next, please. Okay. The project is nearing its end, and we are at the moment completing the performance measurements of technologies developed within the project. We have 11 partners from 8 countries, from Portugal, UK, Turkey, France, Germany, Spain, and Finland. And next, please. We are going to develop solutions for the building envelope, bioaerosol, thermal insulation, breathable membrane, phase change materials, PV vacuum glazing, daylight louvers, also to the use of renewable energy sources, geothermal and solar assisted heat pumps, ventilation and heat recovery systems, and PVT solar collector. And other technologies for heating, ventilation, air conditioning, and lighting, like evaporative cooling and smart controls. Next, please. We have tested the application of Surefit solutions in 5 countries with very different climate conditions, with heating degrees ranging for 840 to 4,000 degrees per year. Next, please. Who have tested who have deal with these energy conservation measures in buildings knows that there are countless possibilities to make a home more efficient. Therefore, a tool was developed within the project to assist decision-making by balancing environmental, economic, and social criteria. This tool is perfectly aligned with the new EPBD review, and is now also available on our project webpage. I strongly suggest that you visit it. Next, please. That's it. Now, let's see what was done in the brick demo building. Thank you.
And now we can proceed with the next presentation. Thank you very much, Sergio, for this presentation. Let's proceed now with Maria Pappa, and we will see what has happened in this building in Peristeri.
Good morning, everyone. My name is Maria Pappa. I'm a chemical engineer, and I work in AMS as manager in the EU projects. And today we will give a presentation about the Greek case study in the framework of the Surefit project. And in this slide, you can see the main technical team that worked in the Surefit project for almost 4.5 years. So Sofia Papadopoulou is a mechanical engineer, and also Konstantinos Tsoutis, construction manager, that is also the managing director of AMS. So I will start by giving a very small introduction about the Surefit project. As it was also mentioned before, it is about sustainable solutions for affordable retrofit of domestic buildings. So the focus was on residential buildings. And the main objectives that were also mentioned by Sergio is to demonstrate fast-track renovation of existing domestic buildings, integrate innovative, cost-effective, and environmentally conscious technologies, reach the target of near zero energy by reducing the heat losses through the envelope of the building and energy consumption for heating, cooling, etc., while at the same time we had to increase the share of renewable energy in buildings. And finally, we had to follow a systematic approach involving key stakeholders, so building users, building owners, manufacturers and developers of products and services related to space heating, cooling, domestic hot water, power generation, etc. And also, as showed before, we had to demonstrate the Surefit technologies in representative buildings in different European climates. So, as you saw before, we had a number of available Surefit technologies. Thermal insulation materials like bioaerogel, prefabricated panels, phase change materials, photovoltaic vacuum glazing windows, solar-assisted heat pumps and ground source heat pumps, integrated solar thermal and PV systems and lighted devices and other technologies as well. And we had to decide which of this technology can be implemented in the Greek demo site in order to achieve the main goals of this project that I will show you later. So these were the technologies that we had to deal with, and now I will describe the building and the apartment in Greece. So it is a floor apartment in a 3-story building. The apartment is the one that you can see in the yellow framework that was built in 1981, and it is located in the city of Peristeri in Attica, Greece. So we are talking about South Europe, Eastern Mediterranean country, and the climate type is hot summer Mediterranean according to the Köppen climate types. The orientation of the 2 main facades, as you can see in these schemes, is north and south. Moreover, the building and the apartment of the 1st floor that we worked with is attached with 2 other buildings on the east and the west sides. So we can assume that it was kind of protected by the neighbor buildings that were occupied and cooled and heated. Below this 1st apartment, there is a floor, the ground floor, that consists of 2 spaces that used to be shops, but not anymore. So this area below this apartment is not regularly used, heated and cooled. The 1st floor that interests us is 1 family apartment, 4 persons are living, of approximately 90 square meters. And the 2nd floor, the floor above the apartment that we worked with, is also another family apartment of approximately 90 square meters. And in this scheme, you can have an idea of the dimension of this building. It is approximately 8 meters long and 15 meters wide. And if you can see in the scheme, it has a living room, 3 bedrooms, 1 kitchen and 1 bathroom. The building is constructed with concrete pillars, and the walls, as you can see in the photo on the right, are made of bricks of 6 hollows with the dimensions 19 multiple 9 multiple 6 centimeters, using an installation methodology of single brick, a gap, and another single brick. And this gap was filled when it was constructed with polystyrene layer. But throughout all those years, more than 40 years, we assumed, and this was correct because we saw this during the construction activities, that this layer was destroyed. Moreover, this building had sliding SAS balcony doors, single glass, 8 millimeters with aluminum frame, awnings. Heating was applied through diesel boiler, the cooling was supplied through air conditions, and the hot water was supplied by low pressure water system from a triple energy boiler. So what are the apartment's needs according to the opinion of the people who live in this house? We had discussions with them, we shared questionnaires with them, and as you can see in this graph, the 4 occupants mentioned that the temperature inside the house was too cold during winter, cold in autumn, too hot in summer, and neutral in spring. So improvement of insulation should take place and improvement of the heating and cooling of this house. Moreover, the users, the occupants of this apartment, said that they had heating issues through the windows because they had single glazed windows. And below, in the graphs below, you can see that they were very much annoyed by the noise coming from outdoor activities, from outdoor leisure, from the neighbors, from the road traffic. And in general, when they were asked about the most important needs of this apartment, they said that it had to do with the heating, with the cooling, with the noise, and the temperature. We did a leakage testing in this apartment using the blower door methodology, and this showed that all frames had strong inflows on all sides, and we had a high index 6.27 of uncontrolled exchanges per hour when we applied 50 Pascal pressure, and this is a particularly high percentage of losses from the entire building cells. And this results in the ineffectiveness in heating and cooling system of the apartment before the renovations. We did also thermal imaging, and as you can see from the shots from the interior of the house, there was poor thermal and air tightness properties of the existing frames and windows. Now, regarding the renovations that were decided, first of all, Aalto University, that is partner in the Surefit project, performed the energy simulations by using the EDA software. So in this table, you can see what is the original purchased energy before the renovations, 120 kilowatt hours per square meter. The primary energy before the renovation, 143 kilowatt hours per square meter, and the CO2 emissions were estimated to be around 36 kilograms per square meter. And during this modeling, by applying a number of Surefit technologies and one commercial technology, and by taking into account the needs of the apartment and the owners, we had the final case that we expected to reach 62% reduction in the purchased energy, 61% in the primary energy, and 61% in the CO2 emissions. So what were the renovations that have been decided? We decided to insulate, as you can see in red, the ceiling of the workshop that is located on the ground floor below the apartment, because, as I said before, this space is not properly cooled and heated. We decided to insulate the southern and the northern facades externally. We installed a PV vacuum window in one balcony door of this apartment, and we choose only one because this is a technology coming from a university, so the resources and the capacity to manufacture big units was not easy. And the rest of the balcony doors were replaced with commercial double-glazed PVC balcony doors. And finally, we installed the PV thermal system for electricity production, domestic hot water, and space heating. So I will start with the first installation, is the PV thermal system. Mahmut from SOLIMPEKS will give a short presentation after my presentation, so there you will have the possibility to hear more details. But a PV thermal collector is a combined collector from a PV module for the generation of electrical energy with a highly efficient solar flat collector for the production of heat energy. And you can see the solar to electricity conversion efficiency around 20%, the solar to thermal conversion efficiency around 47%. You can see the lifespan of this technology, more than 20 years, etc. So we had to install a tank, the solid tank of this system, and the only space available in this building was the ground floor. We had to demolish an existing water closet in order to put all this equipment. And we had, of course, to do the piping and wiring connections and pass them through the first and the second floor in order to reach the terrace where we install the PV panels. This was the first technology. The second one was a commercial technology. As I mentioned before, 3 balcony doors were replaced with commercial systems, PVC double-glazed windows, PVC frame. You can see the U value of the system, and of course, external aluminum rolls. So we had to remove the balcony doors. The existing balcony doors were sliding doors. So after the removal, we had to cover this gap that was created. And for this, we used a commercial thermal insulation panel and installed the new balcony doors. The third technology is a technology coming from Winco, and is the Skytech Pro XL membrane. This is the membrane that we used to insulate the ceiling of the ground floor, 26 millimeter Skytech membrane. You can see the thermal conductivity, 0.029. You can see that it offers sound reduction. It is available in 3 thicknesses, etc. Just to mention here that this product is mainly installed to act as a rain screen in an existing facade. And to operate efficiently this membrane, a ventilated air gap is needed on the external side of the membrane. In the Greek demo case, this was not possible. It was not possible to install this product like that due to the restricted height of the facade and the balconies. So we decided to try this product as only thermal and sound insulator for the ceiling of the ground floor. So we had to remove the false ceiling of the ground floor that existed. We had to place a frame, and on top of this frame, we put the membrane. Reinstallation of the false ceiling, and do the final painting. The fourth technology is coming from the CJR, that is partner in the Surefit project, and is the prefabricated insulation panel. So the idea was to put thermal insulation on the north and the south facade of this apartment. And it was chosen a sandwich-like panel of 30 millimeters commercial polyurethane panel plus 20 millimeters aerogel blanket commercial plus 20 millimeters XPS panel. The thickness is 7 centimeters because we had this restriction for this building. And you can see the U value of the system, existing wall plus the panel is 0.22. So we did the installation as we do the installation of commercial thermal insulation panels, ETICS. So we put an adhesive at the beginning, we placed the panels. Of course, we had to cut them in the appropriate dimensions and also drill holes for the piping from the air conditions that were existing. We put sealant between the panels to seal the gaps. We did the fixings. We placed the reinforcing mesh, the mortar coat after that, and the decorative finishing. And the last technology in this building was the PV vacuum glazing from the University of Nottingham. You will see more details about all these technologies after my presentation, but to have an idea, this is the system that you can see in this scheme. It consists of 2 glasses, and in between them there is a thin film of a PV layer. Then we have an air gap, and a vacuum layer, and then we have the low emissivity coated glass. And you can see the U value of this system, 0.45. The thickness, 8.3 millimeters, and the light transmittance is 70%. So we install, as you can see, this system in a double balcony door in the south facade of the building. Now, regarding the evaluation of all these renovations, based on the data that we have from the energy monitoring, we put energy meters, so these are real data. So you can see the total electricity consumption for this apartment from the grid before the renovation, 5,600 kilowatt hour per year. And in the post-renovation phase, we have 2,400 kilowatt hour per year, plus 1,800 that is coming from the PV panels that we have installed. So transforming them into primary energy, we have a reduction 56% between the pre and the post-renovation phase. Regarding the oil energy consumption, before the renovation, it was something like 5,000. After the renovation is 2,300. So the corresponding primary energy consumption reduction is 52%. And regarding the total primary energy, the reduction that has been achieved due to the Surefit technologies is around 55%, which is very close to our target that was 60%. Regarding the CO2, the total CO2 emissions, the reduction is again 55%. The target was 60%. Now, this 55% total primary energy reduction can be attributed to the insulation of the apartment with a prefabricated panel from CJR and the Skytech Pro XL membrane from Winco. It is also attributed to the PV thermal system by SOLIMPEKS and also to the replacement of the old balcony doors and windows. And for this, we did another air tightness test after the renovations. And you can see that before we had 6.2 air changes per hour. When we replace the balcony doors, we have 2.2. So we achieved a 65% improvement of the air tightness. And now we have this satisfactory index of losses from the entire building cell. And this increases the efficiency of the heating and cooling system of the apartment and confirms the quality of construction interventions regarding the air tightness. Now, this slide is about the feedback that we received from the occupants before and after the renovations. So the most significant outcomes from this discussion was that during the spring, the temperature inside the house was neutral before, it is neutral also now. During the summer, the people were feeling too hot before, now it is neutral. During autumn, it was cold, now it is neutral. And during winter, they were feeling cold, now they feel hot. Also, the building during the winter was slow to heat it up, now it is quick. During the summer, it was slow to cool this apartment down, now it is quick. Also, regarding the noises coming from outside, before they were extremely annoying or very much annoyed by the outdoor noise. Now, this has very much been improved. They are slightly annoyed. And this is not only because we changed the balcony doors. This is an information that came from the people who live in this house. They had a significant reduction of noise coming from the ground floor. And this is due to the Skytech Pro XL membrane that was used to insulate the ceiling of the ground floor. And of course, they don't have any overheating issues through the windows anymore. Regarding the economic evaluation, you can see from the LCC, the life cycle cost assessment, a comparative analysis between a commercial EPS system that is used as insulation material, the breathable membrane from Winco, and the prefabricated facade from CJR. So here you can see that the cost, the outcomes regarding the cost is very much comparable between the EPS and the breathable membrane. For the prefabricated facade, the cost is high, but this is due to the fact that this is not a commercial product. So we have high manufacturing costs at this time. This can be improved in the future. Regarding the PV thermal systems, you can see the comparison between the PV thermal system from SOLIMPEKS in gray and a commercial system of a PV plus solar collector. So here you can see again that we have comparable results regarding the life cycle cost assessment between these two technologies. And this is the life cycle cost assessment of the PV glazing systems. So in gray, you will see the PV vacuum window from UNOTT, a Surefit technology, that is compared with a commercial system that consists of a PVC window and a photovoltaic system. And here you can see that we have 25.5% improvement regarding the cost. I forgot to mention that all this analysis for all technologies is for 30 years. So we have an improvement by 25% by using the Surefit technology here. And this is the LCC comparison between the base case is the do nothing case, what is happening when we don't do any renovation in this building, between the Surefit technologies in gray and conventional technology. So you can see again that the Surefit technologies have higher costs, but again, lower costs compared to the do-nothing case. And this is the final graph. It has to do with the payback period. We had a target to achieve a payback period of less than 10 years for our technologies. This was achieved for the breathable membrane of Winco, and very close was also the PV thermal system with 10 years, 0.63. For the PV vacuum window and the prefabricated facades, the payback period is high, but this is again because we are not talking about commercial products. So the manufacturing costs are very high. And this is the summary of the evaluation results. So you can see that by applying Surefit technologies in this apartment, we have a 55% reduction of the total primary energy and the CO2 emissions. We have 42% of the electricity needs coming from the photovoltaics that were installed, 65% improvement of the apartment's air tightness, 25.5% improvement in the life cycle cost analysis for the PV vacuum glazing compared to conventional technologies, comparable life cycle cost assessment for the breathable membrane and the PV thermal system compared to conventional technologies. We achieved the payback period of almost 6 years for the breathable membrane and almost 10 years for the PV thermal system. The payback period for the prefabricated panels and the PV vacuum glazing system is more than 10 years. It is out of the scope. Unfortunately, we did not achieve any installation time reduction compared to conventional systems. The installation time is almost the same. And the last point is that we received a very positive feedback from the occupants related to the building performance. So that was all from my side. I think that it will follow a very short video showing the installations. Thank you very much.
Thank you, Maria, very much for this presentation. Are we going to watch the video now or at the end of all presentations?
It is up to you.
Okay, let's see it at the end of all presentations, so it will work as a summary. So we just saw all these impressive results from the Greek demo in Peristeri. Thank you, Maria. Now let's proceed with the presentation of prefabricated facade panels by CZR. Pedro Vilela will present, and they have a brand name, which is Sapeti. Pedro, the floor is yours.
Hello, can you hear me properly?
Yeah, we can hear you. And now we will start sharing your presentation in a few seconds.
Okay.
And when you want us to change your slide, just say next slide and we will do that.
Okay. I'm sorry, just...
Can you see the presentation? We can see it.
Yeah, I can.
And it's the updated one.
Yeah, okay. Kalimera Seolos. Good morning, everybody. Yeah. My name is Pedro Vilela. I work at the company CJR in Portugal. I will present the technology we developed, the prefabricated insulation panel with silica aerogel, and this presentation will be in English, of course. Next, please. Yeah. Okay, our technology is a prefabricated panel with silica aerogel, and we named it as Sapeti. So silica aerogel prefabricated panel for external thermal insulation. Next, please. Well, as a construction company, we know that the construction of residential buildings is one of the most important sectors nowadays, especially in Portugal. Residential buildings are crucial to a society. However, there are issues that cannot be put on standby just because housing is urgent. The conscious use of resources is something that concerns us daily, making construction and the company itself environmentally sustainable. Furthermore, we have also focused on the comfort of the inhabitants, and this technology mainly allows an improvement in their natural thermal comfort. Please. Next, please. Okay. The silica aerogel, no, sorry, the previous one. We have some delay here. So. The silica aerogel blanket is an excellent insulation, which allows with little thickness to obtain results like other materials on the market. However, to make its application faster and more efficient, it was decided to prefabricate the technology and convert the already known external thermal insulation composite system, the ETICS, into the one we present today. Our insulation panel, SAPETI, combines silica aerogel in a blanket with the more rigid insulation material to provide more resistance, better handling, fixing, and making it prefabricated. Next. Well, we developed two different solutions, one for Spain with 20 millimeters of XPS plus 20 millimeters of silica aerogel and 20 millimeters of XPS. And another one to Greece with 30 millimeters of polyurethane attached to the building, plus 20 millimeters of silica aerogel and 20 millimeters of XPS. We already made some tests to determine the thermal resistance of a building component, in that case, the prefabricated panel, and also to get the U value. Next, please. Thermal conductivity refers to the ability to conduct or transfer heat. It's measured in watts per meter Kelvin, and thermal transmittance, also known as U value, is a rate of transfer of heat through a structure, which can be a single material or a composite, in that case a composite, divided by the difference in temperature across that structure. So the units of measurements are watts per square meter Kelvin, and the better insulated a structure is, the lower the U value will be. Obviously, the solution for Greek pilot is a solution that allows less heat transfer due to its thickness, and it's a better one. Next, please. So currently, the panel is produced manually, a process that ensures attention to detail and the quality of the final product. However, this method requires more time and entails higher production costs. And if this solution is implemented on a large scale, the production process is expected to become automated and significantly reducing costs while maintaining high quality standards. Next, please. We'll see a video of that production. As it was not possible to obtain a 20... No, you can't hear me. Well, as it was not possible to obtain a 20 millimeters silica aerogel blanket. We requested a 10 millimeters blanket, but with one side covered with aluminum foil, which allowed it to be glued to the more rigid panel XPS and polyurethane, as we have seen on the video. And after that, we joined the two parts with the help of screws, which allowed a better handling, possible cutting when placed in the building, making this technology extremely flexible for any building and facade. And I'm sorry. By associating silica aerogel with an insulation panel, it is possible to obtain excellent thermal insulation. Silica is very good on thermal insulation. Lightweight, this prefabricated panel is lightweight. A reduced thickness, for example, in the case of the Greek pilot, we already need 7 centimeters. We can get strength and durability. The panels are robust and resistant to various weather conditions. We also can reduce the energy consumption. When we talk about prefabricated panels and standard measurements, we can reduce energy consumption, especially on transportation, and we can get indoor comfort, of course. Next, please. I would like to draw your attention to the introduction of prefabricated panels in Spain. This application is tailored to meet Spain's specific climate and regulatory requirements, ensuring effective thermal insulation. Next, please. Here we can see the pilot project in Spain, a key milestone in validating the performance of our panels. The building's location and type are carefully chosen to simulate real-world conditions. And here we can see the 3 houses in Spain, Valladolid. Next, please. This slide details the installation process of the panels in Spain. Challenges such as adapting to existing structures are addressed effectively, and the feedback received helps refine our approach. This technology was installed by FSCM, of course, but we produced the prefabricated panel. Next, please. So the mess is real here. We can see a lot of cables, holes for the windows, corners, and even so, our prefabricated panel was installed successfully. So it can be adapted to the structures. Next, please. So this slide transitions to the Greek market. We adapted our prefabricated panels to meet the unique climatic and structural demands of Greece. Next. In this case study of a Greek apartment, the panels are optimized to adhere to local constraints. They maintain a thickness of 7 centimeters while achieving the desired U value for energy efficiency. Next, please. Here we can see the facade where our prefabricated panel was installed. This one and at the north and the south. 2 facades, I'm sorry. So we can now examine the technical composition of the panels, as we already said, and Maria also. We have 30 millimeters of polyurethane, the lower and white layer, 20 millimeters of silica aerogel, the one at the middle, and 20 millimeters of XPS, the blue one. This combination balances cost, thickness, and thermal performance, achieving a low U value. As you can see, 0.22 with the facade, the panel and facade. So this slide shows the use of scaffolding during installation, ensuring safety and efficiency in applying the prefabricated panels. Next. This one demonstrates how the panels can be customized in the shape to meet various architectural needs. This flexibility is a key advantage of our technology. Here, we can discuss the adhesives used to bond the panels to building surfaces. These adhesives ensure durability and a stronghold. So we used adhesive, but we also need fixings. And this one focuses on the fixings used in the installation process, which guarantee stability and long-term performance of the panels. The role of sealants is highlighted here, emphasizing their importance in preventing moisture infiltration and enhancing the longevity of the installation. This slide explains the application of mortar coats and reinforced mesh, which provide mechanical strength and additional protection to the panels. These layers are important to get some strength, and we also use that on a thick system, for example. Next one. So here we explore finishing options such as primers and decorative coatings. These contribute to both the aesthetic appeal and durability of the installation. I want to refer that all installation was conducted by AMS. We only supplied the prefabricated panel. We would like to summarize the technological advancements of the Sapeti panels. Their energy efficiency, ease of installation, and comfort are the most important advantages, along with their role in promoting sustainability.
Well, Pedro,
so thank you for your attention.
Thank you very much for your presentation. Let me remind you that you can ask your questions in the chat area, and we will reply to everyone by the end of the presentations. Let's proceed now with the presentation of the PV thermal system technology by Mahmut Buker from SOLIMPEKS. Mahmut, the floor is yours. And now your presentation will be shared.
Okay, thank you, Themis. Hello, everyone. This is Mahmut Buker from SOLIMPEKS Renewable Heating.
Could you increase the volume a bit, Mahmut, please?
Sure, maybe it's...
Yeah, that's better. Closer to the mic.
Is it okay now?
I think yes.
Okay, hello, everyone. This is Mahmut Buker from SOLIMPEKS Renewable Heating Company. And today I'm going to talk about a bit SOLIMPEKS and introduce you the innovative PVT technology that we installed in a building in Athens as part of the Surefit project. Next, please. So SOLIMPEKS is a renewable heating company located in Konya, Turkey, producing solar thermal collectors, hybrid PVT collectors, heat pumps, and boilers in 30,000 square meter production area. Apart from that, we have SOLIMPEKS GmbH in Germany, in Hanover, mainly for European market. And we are commissioning second factory, which will be functional in the first half of this year for integrated boiler and heat pump systems. Next, please. So looking at our product range, we have a hybrid PVT collectors that we installed as part of Surefit project, and that you can obtain both electricity and the thermal energy from a single panel, the first one on the left-hand side. And we also have Excel and Winder series of solar thermal collectors that you produce only thermal energy from these collectors. Next, please. So we are also producers of heat pumps, and our heat pump series are from domestic use to swimming pool applications. And the first one on the left-hand side is the hot water heat pump. It's an integrated unit for domestic use, as the bottom is the hot water storage boiler, and the top is the heat pump, the head. Our heat pumps now are in the list of is the heat pump subsidy policy of Netherlands and the Pappa list of Germany, that users in Netherlands and Germany can use government incentives by installing our heat pumps. So we also have high capacity heat pumps, which are from 100 kilowatts to 200 kilowatts, and they are appropriate for commercial and as a substation for district heating applications. Next, please. We offer hygienic tanks in various capacities from 100 liters to 1,000 liters, and these systems are also suitable for solar applications. Next, please. We also have enamel coated tanks, which will be produced in the second factory, and the capacity is 100,000 units per year. Next, please. We produce flexible hoses for mainly hot water applications, from boilers to solar thermal applications. Next, please. We also have a... Next, please. Themis, please. Yeah. This is the new product that allows you to obtain direct heating from the PV panels. This is actually a control box, and which controls the electrical resistance heater inside the boiler, and which has 99% efficiency, and it allows you direct heating from the PV panels. Next, please. So this is pretty much SOLIMPEKS. We have plenty of references all over the world, including 96 countries, UK firehouses, US, South Korea, and Greece, Spain, and France. So we have presence in 96 countries. Next, please. So we have more than 20 certificates, and the PVT collectors that we installed as part of Surefit project has Solar Key Mark certificate. So we can export these units to all over the world. Next, please. We also have SOLIMPEKS Academy. I think it is worth to mention here, where we train engineers and contractors, installers, students about solar collectors, heat pumps, boilers, solar carports, and we are also providing training about nearly zero energy building concept, which aligns with Surefit goals. So in addition to our technical capabilities, we can also take part in dissemination activities as well. Next, please. So this is the Surefit project. It's been mentioned already. Next, please. So there are 5 locations inside Europe, including Portugal, Greece, Spain, and Finland. So we installed PVT panels in Greece and Spain. Next, please. So this is the technology that we mentioned so far. This is the PVT panel. And I think we installed the panels in 2023 in a Greece case. That panel has a monocrystalline solar cell. So on the looking at the layers on the top, there's a glass layer for a cover, And the second layer is the monocrystalline solar cells. So solar cells producing, you may already know that, the solar cells producing electricity, and some other insulation layers. And underneath additional layer pipes, the circulating water and the solar liquid inside the pipes, and which provides active cooling of solar cells, because every 10 degrees increase in the solar cells results in 1% decrease in the PV efficiencies, and the maximum PV efficiency, commercial ones I am talking about, is around 20% now. By combining a solar thermal system and the photovoltaic system from a single panel, you can get both electricity and the thermal energy from a single panel. The PVT panel that we installed in the Greece case has the electrical capacity of 325 watts, and it's around 800 watts. I think this is not the updated one. Sorry, Themis.
Okay, so it's not the correct.
Yeah. I have additional pages.
Would you like to share from your computer now?
It's okay. Do you mind? Yes.
Yeah, we can stop sharing. Alex, we can stop sharing, and Mahmut will share from his computer.
Let me just.
But if you could improve also a bit the mic, because you sound a bit very.
Yeah, maybe.
You did something before.
Is it okay now?
Now it's perfect. Yes, now
It's perfect. Okay.
You did something previously, but now again, yeah.
So, I should.
Okay, can you share now or not?
Let me just hold on, please. Share. Yes. Just a second, please.
Yep. Please, if you have any questions.
Yeah, just please interrupt me if you already have questions.
Yeah. Let's put them in the chat area, and we're waiting for the new presentation to be shared. It's the one you sent us, Mahmut, a while ago.
Yeah. Okay.
Okay.
Can you see it
We
now?
can see it. Just a sec. And we can see the Greek case now, yeah. You can start.
Okay. Okay, this is the building Maria has mentioned already, and on the left-hand side you can see the technical paper that we studied through the satellite views of the rooftop, and we have installed 12 panels on the rooftop, and we also considered shading effect and the mobility and the solar cabling, and 12 PVT panels that has been installed, and a 3 kilowatt capacity of Y-way inverter, 2 units, and 2 units of solid tank 300 liters, and some DC 100 meters of DC cabling, control units, mounting sets, and the fitting material has been installed already. Sorry. So on the right-hand side, you can see the technical schematic diagram of the system that has been installed. And the solar panel is facing the sun. And so you actually, the pipes under the photovoltaic layer captures the heat accumulated inside the panel. And then the mixture, water and solar liquid mixture carries this thermal, the heat to the boiler system that you can see it in the front and through the serpentine. And inside the boiler is full of water, and through these serpentines, the solar liquid that gets heated from the gets heat from the PVT panels exchange heat in with the water inside the boiler system, and you can utilize this water 50 degrees, 60 degrees, or for around 40 degrees, of course, depending on the ambient conditions, for domestic hot water use, or underfloor heating, or even the boiler system allows you to have some multi-sourcing, like you may have some different heat source, like a gas boiler, and you can couple it with the solar system as well. I think in your case, I think in the Greek case, we couple it with a different heat source. As far as I remember, it's like oil heating system and assisted with the PVT system, right? Okay, the same is for the Spanish case as well. Maybe we can discuss it for later, but 3 dwellings and almost identical 12 panels, and but slight changes in this case as well. So this is actually a very important page. So if you just for the energy efficiency, if you just install PV solutions, you may get around 20%, because commercially available PV solutions have 20% electrical efficiency. But if you use just solar thermal collectors only, it's around 40 to 45%. And in this case, for the PVT panel, it's 47%. But if you combine photovoltaic with thermal solutions, you may get more than 60%, because 45%, around 45-50% thermal efficiency you may get from the thermal side, and to around 20% electrical efficiency you can get from the photovoltaic side, which counts like 60%. But after that, even more, if you can assist this PVT system, if you can couple this with the heat pump system and thermal energy storage system, you may end up getting like more than plus 80%. This is the real value actually occurs here, because the real energy conversion efficiency marks the highest efficiency here. So, of course, this is about the project, but maybe small remarks that I can share. Technology shifts, and now we produce 540 watts of electricity you can get from a PVT panel, even 860 watt electricity thermal PV panels on the market now. The price are decreasing because the efficiency of the panels are increasing, but around Europe still installation is a real hard case due to the lack of installers. So we are also involved in another project, Greek-Turkey Solar Energy Excellence Hub project, and we are planning to start a new project. Actually, we will be installing heat pumps in Athens in a new project in this new year, hopefully. So we will be in Athens even more and visit more of Athens, let's say. Okay, this is thank you.
Thank you, Mahmut.
For listening to me, and this is pretty much of my presentation today. But if you may have some questions, please
Yeah,
DM me or just directly shoot out now.
There are several questions. We will answer them by the end of the presentations. Let's proceed now with the presentation of, thank you, Mahmut, a lot, with the presentation of the PV vacuum glazing window by UNOTT. It's a presentation recorded by Benson. He is not able to present now, but he's online. Maybe he could answer your questions, but we will see his presentation on video right now.
Hi, I'm Benson from the University of Nottingham here in the UK, and I'll be speaking about PV vacuum insulated windows, a technology that allows you to have highly insulated windows and also generate electricity from the same unit. PV vacuum glazing windows combine two things. One is the vacuum insulated windows, which are two pieces of glass and a vacuum in between, and the other one is a transparent PV panel laminated to the window. It can be installed in most every place a normal window could be. And a vacuum insulation provides superior insulation, and the PV panel generates electricity at the same time. Now, windows came from single panels, and they started going to double panels for more insulation. Then double panels with a larger gap insulated with gases like argon. And then to get really effective insulation, they started going to triple panels, triple pane windows. But they became thicker and thicker. But what we offer here is two pieces of glass very close together with a vacuum in between. They're so close together they look like a single piece. And also in between, because of the vacuum, they would collapse if they didn't have supports. There's actually little stainless steel balls or pillars in between to keep the glass from collapsing on each other. Looking at how they compare, so the single glazing would be about 4 millimeters thick and offer a U value of 5.8. The double glazing, 28 millimeters thick, a U value about 1.2. Triple glazing, 36 millimeters thick with a U value of 0.8. This 36 millimeters gets to the point where it's so thick it can't be installed in normal window installation locations. Special framing and structure has to be applied. But the vacuum glazing is only 6.7 millimeters wide and offers a even better insulation of 0.7 U value. So it allows all the advantages of triple glazing plus some, and then being installed in all the places you can install single glazing. Looking at then adding on to the PV onto it is basically the same thing. So you've got the two pieces of glass down on the bottom. The dark blue one at the bottom is a piece of glass, and then in between you have the stainless steel pillar array. Again, those are the little posts that keeps the glass from collapsing on each other when you apply the vacuum. And then on top of that is the photovoltaic glass is laminated on top. Creates one structure, and it's about 7 to 9 millimeters thick. In Nottingham, in our test house here in the UK, we installed a vacuum insulated glazing in a couple places. On the left, you can see the original glazing, which is single and double pane combination on a south-facing window. In that very same window, you've got the vacuum insulated glazing with PV on it, generating electricity. As you can see, it really doesn't affect the room at all. Because it's a thin, it doesn't affect the structure, so it could be installed in most every location. It does have a little bit of tinting to it, but once you're back in the room, you don't notice that tinting at all, even in the gray climate of the UK. It doesn't change the room, and it doesn't change the perception of the room, even though you generate electricity from there now. When you get close to the glass, you can see the PV structure. That's only when you're really close, so you can see those two photos there. The one on the right is right up against the window. And the PV panel there actually reduces transmittance by about 10%. 10% of the light's reduced. But the users had no negative comments about the little bit darker in the room, and they're quite happy with it. And hopefully we can start installing these on new houses. And there's a couple startup companies in the UK doing that right now. In future uses, we've got this is ideal for new builds, retrofit homes, and businesses, large and small, from older homes to new builds. And we've even done some modeling on future PV glazing greenhouses, where the greenhouse generates its own electricity. And the vacuum glazing is so insulative that it can be heated with just the LEDs in many cases. But that's PV vacuum glazing, how it's used, and the advantages of it. And if there's any questions, please forward it through the system, and I'll get back to you. Thank you.
That was the presentation Chris prepared for us. If you have any questions, please just write them in the chat, and he's online. Maybe he will be able to reply. And now let's see a very short Greek video from the Greek demo, and then we will proceed with the Q&A section. This video summarizes everything we have seen up to now. And that was it. And now let's proceed with the Q&A section. We have some questions. The first question, I think, is addressed to CGR. Pedro has already replied, but maybe he can give us again the answer for all of you. The question is, what is the difference between CGR's prefabricated panel and the conventional ethics? Why should someone install this prefabricated panel instead of a non-ethics? So Pedro, what's the answer?
Yeah, as we said, we can get a lower thickness. So to a similar result, Zapati panels are much thicker than ethics. So we can get lower volume on transportation. So CO2 on transportation is significantly reduced, and that's the biggest advantage of our panel.
Perfect. Thank you. We have one more question. I think it is addressed to all the speakers. Which of the described technologies you think that could better fit in the Greek environment and the mentality way of living? No, I think maybe to you, Maria.
Yes, maybe I
Yeah.
can say a few things about this. Okay. I think that, the last years, a lot of houses in Greece are using ethics for the thermal insulation of apartments and houses. So Greek people are very much familiar with this technology. So I believe that the Sapeti panel would fit very nicely to the Greek mentality and the common practices of buildings renovation. On the other hand, we have the PV thermal system. Also, the last years, we have installation of PV panels in Greece. The environment is also very much appropriate for this. And since we used to have solar collectors for heating the domestic water, for domestic hot water, I think that also this technology would not have any problem to be implemented in Greece as a Mediterranean country also. For the PV vacuum glazing window, we are not very much familiar with this kind of systems. I think that the people might have a fear that is coming from the darkness that this technology can cause. But as Chris showed in his presentation, we are talking about a reduction of 10%. And also the people living in the Greek house didn't complain about that. So maybe there is a fear, but on the other hand, practically, it seems that it doesn't causes major issues regarding the light. Maybe this would be more easy to be applied in offices and not so much to residential buildings. So more or less, I think that all the technologies could be very well adopted by Greek people. Maybe the Sapeti and the PV thermal would be more easy.
Thank you, Maria, for the detailed answer. We have one more question. Which of the technologies installed and presented today was the most difficult one to apply?
Okay. In our case, the truth is that we didn't face major issues to install all the technologies. It was as it was expected, and it is very much comparable to conventional systems. But only one thing I can say regarding the manpower that was needed, this was more intense, let's say, in the case of the PV thermal system, because of the demolition that we had to do, because on the installation of this equipment, the solar panels. But again, it was not something extreme. It was something that we expected to happen. It is like other conventional systems.
Okay. Thank you, Maria. Do we have any other questions? You can write them or just ask them with your microphone.
No questions, but maybe I can say additional remarks to Maria's.
Yes, please, Mahmut, but a bit louder. Yes.
Yeah. Okay. I agree with Maria. Mediterranean country and very suitable for PVT and solar thermal applications, and also Greece is very suitable for heat pump applications as well, because temperature does not drop below to 7 degrees, mainly warm environment, and the heat pumps probably have a record performance in Greece as well, and I'm sure in the upcoming days or years you will see a lot of heat pumps in Greece as well.
This is true. This is true.
Thank you.
Thank you, Mahmut. Any other question? Any additional comment? Well, then I would like to express my gratitude to all of you for your active participation and engagement. It has been an absolute pleasure to host this session and to share with you the inspiring journey of the Greek demo project in Peristeri, Greece. We had the opportunity to see the innovative technologies that we have brought this remarkable transformation to life, from the prefabricated facade panels to the advanced PV thermal systems and the PV vacuum glazing window. Each presentation was highlighted with solutions and that give new life to older buildings. A special thanks goes to all our speakers, Sergio, Maria, Pedro, Mahmut, and Chris, and for your expertise and your insights.
Sorry for the interruption. I think
tell me.
Question, yeah.
We have one more question, which I did not see. I was closing the webinar. Has the owner have to receive any kind of training to operate the technologies? That's one question from Joaquin.
Yeah, in our case, no, not actually. You just have to open the underfloor heating vanes or just domestic hot water. You just tap water. It's like, so you don't have to get any special kind of training. But if you would like to, yes, we can provide actually.
Yeah, Maria, any additional
this is
comments to that?
I agree with what Mahmut said. We didn't have to do any special training for the PV thermal system and also for the PV vacuum glazing system to the people living in the house. So it is very easy going to operate these technologies, these two technologies. Thank you.
Perfect. Any other question, remark, comment, additional input? Well, then, thank you once again for joining us today. Stay safe, inspired, and I look forward to seeing you again at future events. Have a wonderful day.